Okay. Well, today we're going to be looking at something that most amateurs are kind of afraid of or don't know anything about, and that has to do with duplexers. In specific terms, the duplexer that I have is a notch duplexer. This is a UHF duplexer. It will actually go down to the bottom of the 440 meg band up to about the 470s. A lot of amateurs, when they're experimenting with repeaters, I've come to find, are kind of drawn to the allure of this duplexer. And this is a mobile notch duplexer, and they're drawn to these mainly because they're very inexpensive. They can be had for about $75. The original intent for these duplexers and why they call them a mobile duplexer is they were used in vehicles, most commonly in ambulances. They were used for full duplex audio to talk back to a hospital when a patient was in the ambulance. And these allowed the mobile unit to converse just like as if they were on a telephone in the days before cell phones were widely used or even available. So it was that was its intention. It's capable of handling a continuous duty load of around 50 watts. I wouldn't do that. They get a little warmer than I would like. So I would say continuous duty of 25 watts with an intermittent duty of 50 watts. They're fairly easy to tune with the correct equipment. And but they do not offer any protection. They only notch out the opposing frequencies between the receive and the transmit, and that's it. And even if we look on the curve here, I'm currently using a tracking generator, which for those of you not familiar with a tracking generator, the tracking generator will generate a sweep of frequencies between in a certain band. This one has a maximum span of 10 megahertz. My IFR 1200 here to span. I have an HP 8924C, has a much wider span, but this works just fine. And what it does is you couple across one section here, and it sweeps between these two sections. And it generates the signals going in to the one section and out, and it listens for them on the antenna port on this particular monitor. And then the spectrum analyzer basically maps the profile of the filter. And you can do this for many other things. You can actually, with a tracking generator, is very useful for creating your own filters and so on and so forth, giving you a real-world display of how they actually behave. But in this case, I have the center frequency here on 449.875, which I use this to test out a repeater of mine that I currently have on the air. And it tracks, and it shows me that I have a notch at 449.875. It shows me the level is about neg 35. It goes down to about a neg, as low as I can see, probably neg 105. So that's a very good notch, more than adequate for duplexing. But as you can see, if I, well, that's actually on the widest setting already. So if you see that up here, the filter's passing all these frequencies and only notching this one, and then it has a slow curve up. Anything up here is attenuated, which, let's see how far up we have to go. Let's see here. So let's go the megahertz, so we go up to 450. And then 460, or 451, 452, 453, 454, 455. it doesn't provide much attenuation, and it's, you start getting quickly, into a passband portion, which passband's kind of a misnomer since this only notches. So its passband is, for all intents and purposes, infinite. So, and then of course if we go down, we start at 449, which is our notch, and then we go down to 448, 447, and at about 447 it's almost passing everything. And at 446 it is passing everything. And that presents a problem when it comes to interference. You can easily have your front end overloaded by out-of-band signals if your front end's not particularly tight or isn't protected with helical coils, which we'll talk about in another video. But the notch is tuned on these particular duplexers by these screws that are on the back, and each screw will move the notch. They're usually slotted. I'm using my Leatherman today. I've got to find the notch here, and then if I turn this notch, you will actually see that bump move through on either side. So this generator is a little limited in its generation capacity. I can give it a little bit more signal. I'm on medium right now. If I go to high, I will see the bottom. Oh, pardon me. I will see the bottom of the filter curve a little bit more clearly. So you can see kind of where it's notched. And if I turn it, you can fine tune it. So let's try another one here. That's another one. You can see how it shifts around. The other thing, when tuning a duplexer, or yes, particularly duplexers, these duplexers, and it depends on the manufacturer, but a lot of them, when you're sweeping between the two ports, you're normally sweeping between the antenna port and the receive or the transmit port. And the receiver transmit port will depend on the direction of the split in which you're using. So you normally have to put a load on the one end. I do not remember if a load makes any difference on this one or not. Let me put this back to medium. But sometimes you get artifacts and misreadings. Let's take the load off. Oh, it's a little tighter than I expected. Come on, there we go. Ah, see, when I take that load off, I get this artifact right over here. So that's due to the unloaded open end, without getting into super specifics of why that happens. So you need to really have a load on it. As soon as I connect the load, the filter curve is back to what I would expect. So this load I'm using is a small load. It comes off of a circulator that we had taken out of service, and it works good for stuff like this, for tuning cans. And I just connect it with a little T. It's what I had available. But these duplexers are really not suited for in my opinion, any repeater setup. They're good in a situation where you have to get something on the air quickly, and you don't have a full-size band pass, band reject duplexer on hand. But they do make actually handy little notch filters for in front of a preamplifier. If there's a frequency that's bothering you, they can be useful in notching out a frequency that may be overloading a preamplifier. But these are not recommended by me and by many others for full repeater operation. I know they're out there. I know a lot of commercial repeaters use them. and they do work. But as far as protection goes for the receiver, and also for keeping your transmitter clean, because a bandpass band reject duplexer will give you filtering on the transmit, give you a pass band in case your transmitter's a little dirty for some reason, which if you do find that happening, it should be corrected anyway. But it's always good. More filtering is better than less filtering, in my opinion. But these aren't that lossy. I typically see, depending on the unit, anywhere between 1.5 dB of loss and sometimes 2. So, and sometimes a little more. I've seen some of them where when you tune them into the amateur radio band, they go up to about 3 dB of loss, which 3 dB is you're losing half of your signal. So if you put in 50 watts, you're going to get 25 watts out. And that's the other reason why I don't like these being run at 50 watts, is because that other 25 watts has to get dissipated somewhere, and it gets dissipated as heat in this, and they get quite warm at 50 watts. So they're fairly simple, and like I said, they're fairly cheap. I used this for a little while as a temporary duplexer for my repeater system that I had up and running before I got my full bandpass band reject duplexer. These are useful if you want to use a small low power repeater at your house as an all-star node. Very inexpensive, easy to tune, fairly easy to tune. One word of note: do not tune any filter under power. Any filter under power. I've seen people tune filters under power using a portable or using a full transmitter. Portable, you may be able to get away with it, but with doing more than, I'd say, 10-15 watts, you risk causing damage to the duplexer as you tune it. You can cause arcing and pitting in some of the internal components, and that may not manifest itself immediately, but down the road it may come back to bite you. So, and I know this is a little bit of a luxury for most amateurs, having a service monitor, but if you do have the means, this is one that I like very much, and they can be had for about $1,500. They have different options. Mine happens to have the tracking generator option, which is very, very nice. So that's about it for notch duplexers. I'm trying to think what I was going to say. Now I remember. The next video I'm probably going to be making is going to be on the bandpass band reject duplexer, which we'll tune one of those up and see how they behave on a tracking generator. And just another word of note. This isn't the only way to tune a duplexer. There are a couple other methods. One method, which is if you don't have a tracking generator, is using a generator source and a spectrum analyzer. It's usually two separate pieces of equipment. The other one is a noise generator and a spectrum analyzer. And the other one is using a return loss bridge. They're all good methods of tuning a cavity, a duplexer, or any type of filter. My preferred method is a tracking generator. It's a spectrum analyzer with an integrated tracking generator. It makes the job very, very easy. And I would suggest anybody that's going to be doing any duplexer tuning or cavity tuning that they should utilize that. So, but everybody's got their favorite methods. So besides that, I'll talk to you later.